Hello boys and girls, Nero's back. In today's topic, I'm gonna talk about lightning. So let's cut the crap and dive right in. Alright, first things first. I want the lightning to emit from the hammer and then hit the ground. And also, let me show you. The lightning is flowing up along the surface of the hammer, right? Check this out. Check this one. It's flowing along the surface. This is what we're gonna do. For that, we're gonna need a crack. That's for sure. Where are you, crack? Oh, here you are, buddy. And I want to limit the frame range from 210 to 300. So let's put a camera here. Yeah, something like this. I don't need the shader. And I only care about the hammer, so I delete the hammer and choose delete non-selected. We only got the hammer, and then we convert it. Yeah, I don't think I need this part. I only need the head of the hammer. Yeah, we can double click it and choose it, or we can also choose 3D connectivity, which is the hammer head, and hit delete. Still, delete non-selected. This is what I get, the hammer. I wanna put a pop network. I want the pops to emit from the hammer, but it's wrong, right? This is not what we want. So why don't we try to find the frame when the hammer head is almost vertical, and do palm shift, lock it here. Okay, bear with me. This time it is here, and let's lower the life expectancy, maybe 0.5, I don't know, and divide by 2. And the attributes, we don't have any attributes for now, so why don't we create an attribute which is v, which is a where is it, a vector, which is pointing up. Let's check this. This is the vector. It's moving up, okay? And this time, this is what we get. Alright. Yeah, first is the speed is kind of okay, but particles is too much. All right. Why I'm keep seeing the hammer? Maybe it's still a displaying bug or something. Oh, wait, let me check. Kind of okay, but I don't want to see the hammer. Yeah, the hammer is gone. The 19 version, sometimes there's a display issue of 19 version. Maybe they're gonna fix that later. And anyway, this is what we got for now. But the problem is, let's put it back to show you. The problem is flowing, that's right, but it never flows on the surface. See, it's out there. So for that, we can use a pop wrangle. To the inputs, we wanna set the input 1, the first context geometry, which is the hammer. And what we're gonna do is we say p equals mean plus function, which is 1 of p. You can see now it's moving along the surface. This is too quick. Make it 0.2. You see, it's moving along the surface, especially on this part. See, check this out. Right? Is too much for sure. We don't want that much. And the next thing is, I don't want this particle to emit from here. That's too high. I only want this guy to emit from here. Okay. We can choose this part. See, I cannot select it again. So, I have to put a box here and try to select it. No nothing, still no nothing. Yeah, it crashes. I don't know why, but it is really okay, forget it. Let's keep going. So why don't we create attribute create, and for this attribute I'm gonna create call this one create v. For the next one I'm gonna call this create emit. The attribute I call it emit, which is integer 1, which is 1. What we get? Let's only check the emitter. See, we got 0 or 1 emission for the primitive. Is that primitive? You are a point attribute? Yeah. So we want to limit to where is that? Emit. See, nothing start from the upper part of the hammer. Okay. And the life, I guess, is too short. Maybe I put it 1. Maybe it's a little slow. Move up, move up, move up. Yeah, something like this. Okay, that's good. But the next thing is, this one never moves, right? We need the particle to move with the hammer. How can I do that? Extract the transform. Connect it to the static one, and this one is from the moving one. We got the transform matrix. We got transform matrix, and let's put a docking part here. Right here, I want to fetch geometry, which is the particles. Then I'm gonna put a transform pieces. Okay, check this one. See, it's now moving with the hammer. And to my like, this is something is wrong here, because the velocity. See, is there any velocity? Let me check it. See, there is velocity, but it's all 0. So you don't have to do this, but I want to make it correct, which I compute the velocity matched by ID. See? Now the velocity is right. We don't have to use that, but in case later we're gonna use it or not. Yeah, that's the first step. Okay, step 2. Let's make our ground. This time I'm gonna try to use the high field. Maybe put 5 by 5. It's a little small. You can make it larger, and for the grid spacing, we'll make it really small, which means give it more division, more resolution. And then we're gonna put a high field noise. You can see there's nothing. because it's too crazy. Let's lower the element size, maybe 0.1. You can see this is crazy. In 0.2, 1, 0.5 is not good enough. Okay, let's make it something like this. But now what we have is just volumes. Later we're gonna use a resop to read the points onto the ground, but the ground needs to be a polygon. Okay, so we convert. There's a I think there's a convert high field, which means it converts the volumes into polygons. It's too much, I guess. Maybe I can lower that. Okay, but we don't do it for now. We just add an all here. Call this one outground. Outground. Okay, step 3. We're gonna read the points from here onto the ground, right? Of course, we're gonna use a resop. We can use mean distance, but this is gonna be ugly. I'm gonna show you. Say we put an add here. Sorry, not before that. We're gonna merge them together and put it here, and we're gonna add them into lines by ID. You can see this is ugly. If I try to show you, see, it always connects, nothing breaks, so we don't use that. So how about we use another function, which is product race, direction from normal. But the thing is, do we have normal? Let's check this. And yeah, you have normal. The normal is from the hammer surface. I decided to put the tube here to represent the hammer. Of course, we only need the sides of the tube. We don't ever need the cups. And we can give it more rows, more columns. Why are we doing that? Is because we can put a normal here, put it onto points. This is our normal, okay? End. You can put a wrangle here. We want to change the y component of normal. We want it to minus, say, for example, I'm gonna say you're gonna minus 0, 1, 0. Sorry. This gotta be that. You can see this is minus 1 or minus 0.5. We can change that, right? So why don't we use a relative bounding box of myself, 0 and p dot y. Sorry, this is the biggest y, this is the smallest y, which means this is 0 and this is 1. So there's a ramp from 0 to 1. Okay, now we can change that by putting a sage ramp. Say y, we call that one this, and put it into a ramp. That way we can control the ramp. Okay, how about I want the upper part of the hammer, which is this part to be mostly horizontal, and the other part they're looking down, which means I can control this, something like that. All right. Let's give us more space. We call this one modify normal, and then let's add a attribute randomize to control the normal, which is 3-dimensional, which is inside the sphere. I want to control you. The direction attribute is normal. We can control it more like this. Yeah, it's not that regular. See, it's irregular now. Why are we doing this? Because I want to use a attribute transfer to only transfer in from here, from here to here. And this is what we get. Where's my hammer? See, it's always moving like that. This way we have our n, which means when the n is looking at the ground, it will work. Okay, and still that's too far to my like. I want limit the max distance. Say this is still too much. I want it to happen, yeah, from here. So that way we successfully limit the lines here. I guess this is let's check it out. Oh, okay, it's kind of okay, kind of cool. And then let's put the resample here. I want to give a 100 segments for each line. And the most important thing, we can use curve view. Let's check out curve view. Curve view, where are you? Yeah, you're here. We got our curve view. And then let's go up here and call this noise lighting. This is actually our main trunk of the lighting. If you're going to see this, this is something like this. The trunk. The lighting is something like a tree, right? So this is the trunk, and this is a small branch. Let's call it here, and let's try to add a noise. Let's say turbulence noise. Sorry, turbulence noise. Gotta be 3D. Maybe original plane noise. Add them together. This will become something like this. And since we have curve view, we can bind it in and multiply our curve view. Okay, here is nothing. What? Yeah, I misspelled it. Let's respell it. Curve U, yeah. Which means this is 1, and this is 0. Okay. Then let's put ramp parameter here. I want it to be a slight ramp. Yeah, we can control that. Yeah, let's hide the other part. This is useless. We can only leave ourselves a hue or something, and we can create input parameters for the noise. Yeah, this is a little confusing. So let's put a separate line here, and we can control it and lower it this way. See, this is the biggest part, this is the lowest part. We can always control it. right? Make it crazier. Give it more frequency. It's moving. This is what we get. I guess this is too much. Okay, we can always change the seed. The dot inside F, so we got a different seed for each frame. So now it's moving. This is our main trunk. Okay, first step is a little tricky. For that, we're gonna use a for each, sorry, not for each, for loop with a feedback. We connect in. For the iteration, let's put it 2 here for now. And let's make a line. The line needs to be Z direction. See, this is Z. See the gizmo? And the length, let's put a 0.2 here, maybe. Just leave it for now. And say copy 2 points. We're gonna copy the lines onto the points, which is our main trunk. But right now it's everywhere. Now each point, remember, we got 99 dots for each line, which is too much. So why don't we use group by percentage QL? This is pretty convenient. We wanna choose we want to set the class to points and then rename it to say roots. And we only want to keep maybe 10% or 5% of the points, and we can always change the seed. All right. And here, I'm telling you, you just going to copy to the root. Still too much, I guess. So maybe keep 2.5%. Okay. And now it's actually weird because the copied points sort actually recognize N. It will use N for the direction of the line. For that, so why don't we use a polyframe here? And the polyframe, I'm gonna tell you the tangent should be N. But now it's pointing up. Let's put a wrangle here and call this negate N. As you can guess, we're gonna say N equals minus N. So it's putting downward. Let's check the result. For now, it's still some kind of weird, right? What do we have? Do we have N? Let's check out N. There's no N here. See, there's no N. I cannot see N here. Okay, that's weird. So how about I put you here? Yeah, this time it seems right. And we can further manipulate it. First, let's lower the length. It's too long. And I'm just gonna steal one of my nodes. This is called a randomize N. Copy it here. Put it here. So this is before, this is now. We can control it somehow. And this is what we get. You can see the difference. See? That's the difference. Okay. But we have to merge this guy with before. and this is what you get. 2 iteration, 3 iteration. Alright, let's disconnect it for now. We're still gonna noise this one, the branches. So can we still resample and root the 3 nodes? Put them here. Wow, this is crazy. Let's check. And merge with that guy. For that guy, we're gonna do group delete. Where are you? We're gonna delete the root group. Oh yeah, I have to rename it. Call it root. Root only 14. So that way, we can always coming up with it. And by the way, by stealing the nodes, we still got our curve view. And this is too much to my like, and I can give it more frequency. Still too much lower now. So that's the result. The theory is every time, say this is the beginning, we got the roots, okay? And for iteration 1, that's the result. The branches and where is it? The branches and the root. Okay, but this time we only gonna do that on the branches, because this side for the trunk we don't have any root group anymore. But this side we do have some root group. Okay, so that's interesting. Let's see how much we can get. That's too small. I guess we can give it more. Yeah, this is too crazy. We can always change the seed. You can always change the seed. It's not seeing the curve view for now. Where's my hammer? Yeah, this is the hammer. It's almost what we get, but this one is weird. Why are you putting up? Let me check. Maybe because this one? It's not because of that. Maybe it's because of the randomize, or we can tell this guy. Let's check out where is it. Let's leave it at 4 for now. I believe we can correct that whenever I want, but I don't want the lining to start from the beginning. I want to start something from here. So let's head back, and I'm going to say that only $sign IFF is bigger than 240, and I want you to yeah, just from here. Let's check out what we get. Something like this. Still, we need to find a way to separate. But still, we need to find a way to separate the branches from the trunk. That way we can render it out separately. So we're only gonna delete that. Let's make another group. Let's call this one. Oh, sorry. Let's call this one trunk. So what do we have? Let's prove to ourselves. Let's blast Sorry, not the root, the trunk. Okay, we separate them out. So why don't we use a split? I'm gonna split the trunk. Put a null here. This code out trunk. Cut this one. Branches. Oh, sorry, I forgot to mention one thing. Is the copy to point sort actually recognize p scale. Let's use actually randomize. Say p scale. It needs to be one dimension. P scale, the smallest one, maybe set it 0.4. And let's see the result. Let's call this one set p scale. Okay, if we try to manipulate the seed, or we can make it grow or shrink, make it more random. Okay, so let's keep going. Okay, next step, the sparks. I'm gonna steal something I did before, copy it here, and connect it to the ground points. See this points, who is hitting the ground, and this is what I did. Yep, since the simulation only starts from 240, let's try to start from here. Yeah, this is what we got. I'm not gonna build this from the ground. I'm just gonna tell you what I did. Okay, first I put everything into just born, and I kill everything but keep the just born group, and then I make the pop replicate and put it into a group, and whenever the heat total, which is here, enter the collision behavior and the compute heat total. When this is greater than 3, and then I kill it, I delete it, and then this is what I get, all the points. And after that, I'm still stealing it. Give it some time. Okay, I did a time blend. Doesn't matter. The matter is I try to use the new sub, which is called particle trail. This is the new sub from 19 version, and this is what I get. All the sparks. So that's it. And I have to add another null. Call this one out sparks. So we got our trunk, our bunches, and sparks, and we need, sorry, wait, another convert. Put a null here. So let's call this crab. And yeah, we already got our ground. So let's put it here. We can call this guy render correct object merge. Of course, we're gonna put everything. You're correct. I like to make the render node red and the sim. Put this sim green. This is correct, and copying it. We can call this one ground. Put the ground here. Where is the ground? No, it's still there. Yeah, that's the ground. And correct. For another one, I'm going to copy this. Spark. For spark here. Okay, sparks. Oh, I'm keep doing that. Sorry. And this one is for trunk. Drag trunk here. And the last one. Branches. Okay, this is what I get. And if I go to stage, which is Houdini's new Solaris system, we can put a scene import. We can import everything here, and you can see it is weird for now because for the trunk and branches and sparks, these are only lines, and when we just imported it in, this is weird. So let me show you what I did before. I'm lazy. I don't want to recreate it again, so I make a maybe this guy. It's branches here, which is this guy. We can manipulate V or P scale here. You have to manipulate the P scale, so the karma render, it will know how thick it should be. Okay, and then I use a collection. You don't have to use it. I made just 2 MTL X, material X, standard surface. One is for spark, one is for lighting, and I connect the display color to the sparks. I don't remember, but if you try to bind the display color here, the Solaris system will understand, oh, say this is yellow, it will import the yellow color and connect it to the channel you want. Right now I connect it to the emission color, which is here. So this is all the correct ground or camera, and the dome light or other light, something like that. If I go back, yep, this is what I get. I just after it rendered out, I went to nuke and add some glow to it. That's it. So the whole point is how to create this kind of lighting here. Okay, that's for today. Like I always said, there's no right way or no only way to do things inside Houdini. You can try different methods, doesn't matter. See what yourself come up with. And there's another shot. Also, I rendered this out by using Karma, and Karma is kind of interesting. Maybe in the future we can talk about it. Anyway, I hope you found this video useful, and I will see you next time.